Hello, everyone, and welcome to Open Source Diaries. My name is Anita, and today I have an exciting topic we're going to look into open source security in open source. And I also have a speaker who is going to be sharing more insights on that, the person of Sal Kimmich. So, Sal is like a privacy and security expert, and she has been doing this for years. And I was dying to listen to her story on how she got into open source and how she is doing it up till date on all of the awesome work. And I'm sure you are too. So just hang in there and stay tuned. Hey, Sal, and great to have you here.
Hello, good to be here. Excited.
Thank you so much for joining us on today's episode. So, Sal, I've been following up a lot about your story, checking out some of the projects you've been working on, and it's really amazing to see you have over 10 years of experience in security, and not just security, you're still doing that in open source. So, can you share a bit about yourself and the professional background, how you got here? And I just really want to know all about it.
Yeah, so I mean, open source is a really, really big world, and security is one of those few things that cuts across everything that I've ever done. So when I first started out in open source about 15 years ago, I was doing brain imaging. And so my first experience with open source was a lot of Python and like matplotlib kind of stuff. And I came up in the world of NeuroDebian, which is really, really interesting because I think in open source, there's a thing that you'll learn about a lot, which is upstream versus downstream. And my career has kind of been working on the downstream at the beginning of just importing and using code. And then as the years passed and we got more and more security threats coming in, you just could not continue working on downstream without at least being aware, and then jumping up and up the upstream and all the way to the secure kernel to try to really understand what's going on there and understand the way that the system of code that we all consume on a daily basis works. Because at the end of the day, there's maybe a few dozen Kubernetes maintainers at the very top of Kubernetes, but if you downstream that and you take that to just a single scientific community, on any given year, there's going to be 35,000 people that are using that just for brain imaging alone these days, right? So it's a massive surface area of developers that might not have a security awareness. So I've been trying to fill the cracks in that system so that developers can just keep going and building without having to deal with security concerns. And it's been a wild ride because we've got a lot of security vectors coming in.
Yeah. So I can imagine how, first of all, that sounds like a whole lot of work. Although I have no idea what it's all about, but it sounds really, really intensive. And I'm like curious, what actually inspired you to get into open source, but then like specific to security? Because like there's so many areas of open source, and I'm just finding out so many others recently. So like, what narrowed your focus down to security?
Yeah, so honestly, my focus in security came from sort of just the natural progression of my career. So I came out of a computational neuroscience program where I had been building out machine learning pipelines. And I was recruited from that into federal contracting, where I was building out scalable Kubernetes. But this was on a defense contract for the Missile Defense Agency. And there may not be a aspect of the DoD that is more serious about real security hygiene than the Missile Defense Agency. And so at the very, very first stages of my career, when most people are getting just their first junior roles, I was coming in already with a PhD, the ability to project manage myself and to manage a team. And I was put into a very, very high security hygiene space where we were taught not only about the best practices for supply chain and vulnerability management, but also things that you would never learn in a corporate space, like how to consider and review inside actor threats, how to not become an inside actor threat yourself. And I found all of that to be really, really interesting and incredibly germane, incredibly relevant to the corporate world because we were seeing security vectors come in to large corporate projects that were intaking exactly the same, very nearly the same Kubernetes version that we were taking in, just without the same hygiene. So when I jumped into public security, which is everything that you can see on my public profiles now, I did that with a very, very, very strong intention. I wanted to bring some of the best practices that I was seeing in the defense space into the normal developer's experience, make them as easy and as automated as possible, and to make sure that we were all sitting on this new baseline of security standard because we're working in an incredibly diffused environment. There has never been another moment in time where effectively in open source, you're creating massive global information aqueducts. And there's systems and ecosystems that work incredibly effectively. But unlike other systems of infrastructure that have ever been built in history before, it's not like a single person created the bricks and the bricks go up and they're there. Every single brick to the open source system that we have here has a maintainer or a couple of maintainers that have to make sure that security vectors don't come into that specific component. And a lot of them have not been trained traditionally to avoid having those kind of security threats come in. So I was looking at this massive infrastructure supporting system. And when I say infrastructure, I really do mean that. I mean the kind of technologies that I aim to support. They are supporting massive energy grids. They are supporting massive like water sanitization systems. They really impact people who don't use the internet. That's the massive impact of doing this kind of security. So I really enjoy now this practice of trying to see and working with what we would call open source stewards. These are the large foundations where they will take in projects and they will maintain them or work with the maintainers to maintain them. Largely, we're thinking the Linux Foundation, the Eclipse Foundation, and the Apache Software Foundation, as well as like language systems like Rust and Python foundations. These groups right now are starting to take responsibility for building out a very basic security baseline that all maintainers on the internet should be able to participate in and use. And that's whether or not you're part of one ecosystem or you choose not to engage with stewardship. Even if you want to be a solo maintainer and build out your own project, which I still really encourage to get the real open source experience, go out, build something and maintain it yourself. If you're just that solo maintainer, security practices are still relevant to you. Your specific project may not be a target at this time. It may not have a massive number of consumers, but if that ever does pick up, having security in place is going to make your life a whole lot easier. And it's going to make it so that you're doing preventative security care rather than coming in and trying to fix up a 0 day. When I say 0 day, this is whenever we have a major cybersecurity exploit. And typically the way that those are going to come down, this is like Log4j, Log4Shell was a very, very clear example of this that everyone knows and still makes everyone, a little bit nervous. But when you have a 0 day, you have this really, really interesting moment in time where you'll have usually a couple of days or a couple of weeks in which the critical vulnerability has been observed. We have removed it from all critical infrastructure systems. I'm talking your power grids, I'm talking your sanitation systems, I'm talking your government voting systems, anything like that, and especially your financial systems. We've spoken and worked and removed and patched in anything that's going to impact just a typical citizen. And then we will announce a 0 day event, meaning you quite literally have 0 days to patch from our moment of announcement. Because at the time that we state there's a critical vulnerability, that's going out to the entire internet, including those that want to exploit it against people. So you're in this race to get it patched. And people that have come up through open source and just want to build out things that are, a neuroscience pipeline or a logging mechanism, and they never saw themselves as being the owners of security for their project, now have to either engage with that or be at risk of not being able to participate in open source ecosystems because they'll be seen as strongly at risk. And I think culturally, uh, we need to make it way easier for maintainers to just work and use these. And we also, for just a standard developer on the internet, you shouldn't be afraid of security. Ignoring security just makes it so that you're going to run into a bigger incident down the line. See it as part of your daily practice as something that you have to learn right now, because it's going to make you a better developer. It might get you into a higher paid job, but it will absolutely prevent you from getting fired because you caused a breach, which I think is incredibly important.
Well, that's fascinating. And I think I'd like to draw back to a point you mentioned that a lot of people get into open source and have zero idea about security. In open source, right, we're trying to get more persons to come into the communities and contribute. But I don't think I have seen a community that actively, does a lot of education about, the security aspects of things and how people should be careful in certain areas. And then I came across a Reddit post where someone was like, how do I confirm that the open source communities that I'm contributing to or I'm using can be trusted in terms of security, considering that they're open and a lot of people are coming in with their contributions, right? So like I
Mhm.
really like that you're able to point to that.
Yeah, I mean, that is an open question. That is a question to some degree that governments are asking right now. So that's kind of the major question that's coming down. So, in the European Union is putting into place the Cyber Resilience Act, which has to be absolutely in place for like corporate consumers and for open source foundations by 2026. And this is the first time that we've seen a large government consortium make a specific ask to have a shared baseline across all open source projects if they're sitting underneath an open source steward or foundation. So we are seeing for the first time that kind of guarantee come into place, which is really, really interesting. So as just an average developer that wants to be able to like pip install or import and not have concerns, we're looking at a different world now where there's going to be projects that are verified and projects that are not verified. There's two different aspects of this, and I'll just go into this lightly because it might not be just for a typical developer. But over the course of about 2 years, we've gone so far as over the Linux kernel to have to ensure now that we understand and have government IDs tied to those that are committing directly to the kernel. And that's an approach that's also starting to come into place around different foundations, like potentially the Eclipse Foundation at this time. So that's an absolutely new world that we're looking at. It used to be that anyone could participate in open source. You could participate in open source under multiple identities if you wanted to, and that was not a major issue. But now there's going to be a largely federated and controlled and security controlled ecosystem of projects underneath the stewards. And there's going to still continue to be the somewhat wild west of true open source, which is still a lot of fun. But there's a lot of security practices that you can do and understand as a developer to be able to still play with those projects, because those projects are way more fun. They're usually the cutting edge. So, a few suggestions if you're just getting started in this and you want to upskill yourself to be able to understand what you should consume and what kind of security hygiene. Absolutely. There are free resources available to you. And some of those resources come with free certifications, which is even better because you don't just want to get the education, you want to prove that you have it if you're at this stage. So there's Linux Foundation offers a like security 101 and a security 121 is the name of the course or the number of the course. And these are cybersecurity fundamentals where you can take this full free course and the exam at the end, and it takes you from understanding the basics of the security CIA triad, which is like confidentiality, integrity, and access or accessibility. And it takes you all the way up through understanding the supply chain, as well as some of the tools that you can put in place. So there's also something called the OpenSSF, which is the Open Source Security Foundation. So the OpenSSF has a security scorecard, which you can take and run on any repository, whether or not it's yours or not. But when it first came out, I ran it over some of my old scripts that I hadn't been touching for like 7 to 10 years from my neuroscience days. And I was very surprised to see, wow, there's a lot of patching that I would have to do if I actually wanted to maintain these. But if you're working on a project right now, what that's going to do is give you a quite beautifully simple checklist of everything that you could do to make your own repository more secure, or everything that you could do to understand whether or not something that you're consuming is doing secure practices. And I'll say one more thing about this, because this is really something that's so important to understand. If you're just playing with open source, understanding a lot of security or cybersecurity aspects that are more around like red teaming and corporate or like penetration testing, those are all good to understand, but you have to understand supply chain security because that's your primary vector. And if you understand hygiene practices and the fact that you can be importing a dependency that could be importing a dependency itself or a dependency underneath that, then you get into a really interesting situation. So we did some research at Sonatype in 2022 to 2023. We found this incredible statistic. So we were trying to find out, is there a way not to figure out if something like not to like work on the 0 days and get those to, get done faster and get people to engage with them because that just clearly wasn't working. We needed a way to be able to identify what projects were the most likely to encounter a 0 day in the next 3 to 6 months. So we did this predictive analysis. We were looking at the past year or two of cybersecurity breaches across languages. So this is including Python, including Rust, including Kubernetes, all of them. Across every single language, what you will know or see is that it is the frequency with which you get the updates to dependencies on the project that you're bringing in. So very much not just are you doing good practices and asking like, am I secure myself? You have to say, is the thing that I'm importing also doing good security practices? Because if you have even a single project that you're importing out of, it could be anywhere between 5 to 115 things that you're importing for a typical like stand up of a Kubernetes system, in that space, if you have a single unmaintained dependency, that's your security vector. If you have 5 of them, you have 5 security vectors, but you only need one. So this is why now we're working on getting you a good baseline. If you're importing something that's maintained by Linux Foundation or Eclipse Foundation, you have to have a guarantee that that's not where the problem is going to be. That then allows us to do the traditional open source security of going in and putting our volunteer efforts around projects that are still developing, that are not incorporated into any of these systems, that probably do have just one maintainer on them that's trying to get the work done, that's trying to build out features, right? And in that world, the one that we're moving into right now, things get really, really exciting because we're at this growing pain right now of asking individual maintainers to do a lot of extra work that is really, really burning them out. And we don't want that. And I don't want anyone's career, I don't want people to think that they have to be security engineers in order to be doing feature engineering, which is a little bit true right now. I want there to be feature engineering completely unlocked with security baselines and security practices that are completely standard and normalized and easy and automated, hopefully.
Well said, Sal. So I love that you pointed out the open SSF principles to actually, help projects and also maintainers ensure like a secure system. I didn't know something like that existed, and I'm sure a lot of people didn't know either. And so many people get into open source without actually taking into consideration the security aspects of things. And when something eventually breaks or there's like some threats due to their contribution, there's like so much chaos. And I'm sure that's why the confusion on whether or not to trust open source projects in terms of security always comes up. And then I'm curious, right? What role do you think open source is playing in addressing like the global challenges with like cyber threats and like system breaches. And also many organizations are currently incorporating open source technologies into their softwares. So like aside what we've discussed so far, is there a way that you think open source is playing a role in addressing this aspect of things?
Yeah, so I mean, it's a huge role. So we understand that open source is not going away. It is impossible for it to go away. We have a system in which, like, our genuine critical infrastructures, and this is across the globe, depend on this technology. But there's sort of two aspects of this that I think you really need to understand security. I'm going to start at the sort of farthest level, which is sort of a downstream developer that's consuming from an ecosystem. So in those spaces, right, if you're consuming primarily Python or primarily Kubernetes, there are security engineers that are always upstreaming or patching. That means like we are identifying vulnerabilities or potential vulnerabilities and then removing them before they become 0 days. And a lot of that is making sure that you understand the language that you're working in. You understand the kinds of loosiness that different, or loosiness or lossiness that different languages can have. Because you've got very different concerns in Kubernetes than you do in Python from the way that the language is developed. And I'm going to say this one time. Creating a memory safe language does not create a vulnerability free language. Not true. It just prevents a single class of vulnerabilities, which I'm glad that we've taken care of. But it absolutely does not mean that you're building securely if you're building in Rust. Not true. That is a false belief. Do not think that for a second. So you have to understand what kind of logical vulnerabilities can you get within your language and make sure you stay up to date with that. Right now, I have a mentee who's going through and working over just getting their first certification for Kubernetes. So they're doing the CKA. But as they develop that through, I'm having them go through, look at, and understand any aspects of it that also apply directly to security and really focus in on that. Because you'll usually do a two-step pathway if you're in Kubernetes. You're usually going to become if you want to take the certification route, you're going to get the CKA, which is the administrator certification, and then the CKS, which is your security certification. And I think right now, if you're starting out in a language and you're really just learning, try to learn both of those at once to some degree, or at least look into what you have to do to understand security principles in your language. You must do that. If you're working primarily in Python right now, there's a security engineer that works full time for the Python Foundation. Go and pay attention to everything that they put out. They put out a blog once a week. That's going to help you to understand how to think about security at that language level. Then there's the middle space, which is where you have to think about the ecosystem that you're using, how different technologies work together. And typically, right now, that's where you're going to see an open source foundation stepping in and putting in baseline controls. So it's something that you might not have to think about so much in the future. You don't have to go and validate the specific package. You do have to validate that it sits within the ecosystem and that it's following baseline practices. One thing that's really important about that we are getting set up right now, is there's this idea of an SBOM, which is your bill of materials, your software bill of materials. A good way to think about this is, can I create a full nutrients ingredients list of everything that is engaged in a product, everything that's imported, and whether or not it's healthy or not? That's good, but we are building right now a system that allows us to do a tested SBOM. So we want to absolutely verify that we have the correct version, it has not been tampered, and you have a complete guarantee that what you're importing is what you want to import. So sort of one of these vulnerabilities, not vulnerabilities, but one of these vectors that was really major a couple of years ago was typo squatting, which is, I mean, one of my favorite things to look at into, because the stories I think are a little bit funny. But one of the biggest things that is imported from Python is matplotlib, which is not the easiest thing to spell. So there were a bunch of typo squats in a given year where they would put two P's into it or two M's, just slightly misspell it so that you think you're importing matplotlib, but you're in fact importing a completely different system, something which is intended to cause harm to you. It could even look almost entirely like matplotlib when you install it, but it'll have a backdoor in it, or it looks entirely like matplotlib, or it's going to run an executional underneath that you can't see. Those are the kind of things where they're aiming at developers that have no security experience, and all that they're trying to get access to is the computation on your local system so they can exploit it. So that's really the kind of security events that you'll see around anything that touches computation. That's really where they're aiming at now. They want to take your compute. And they were reasonably successful in this for a couple of years. But now, if we get attested SBOMs done, you should be able to absolutely verify that yes, for sure, when it lands on your computer, you are getting the correct matplotlib. You know that everything that matplotlib imports itself is also verified. And there's no opportunity for any of those scraggly little unknown executes to jump into your code. Because we are way past the point of security engineers doing what they did in the 90s or before, which is actually looking at individual lines of code. You do have to have a layer of operational trust. And I will extend this one point farther back to log4j log4 shell, the very traumatic log4j log4 shell. This was something that impacted most of the internet because it was just a logging mechanism. The things that they were going after were primarily things like blockchain systems, things that don't even run in Java. But you would wrap a Java logging mechanism around them. So it had this massive surface area of effect on people that were either not security oriented or had a false belief that they had no security concerns because they were building something like blockchain, which, yeah, does make some guarantees internally to its system. But when you throw in some Java, you've got the same security concerns as throwing in some Java. So those are the kind of things that you have to think about if you're building a system that's going to import many packages, which open source, that's the name of the game. That's what we do. We borrow people's work so that we can build new work and make it more interesting and hopefully contribute back to the project that helped you get it done. Now, there's one more thing, and I'll stop here after we go into the kernel. So there's kernels. There's a couple of them. There's the Linux kernel, there's the Microsoft kernel, and within these, when I say the Linux kernel, there's several different versions of the Linux kernel. So there's the mainline kernel, there's the long-term kernel, there's the real-time kernel, which has just been integrated, but there's also a kernel that is the security kernel, which has been one of my fascinations for a long time, because a couple of years ago, I was studying the information systems sitting on top of kernels, and it's a really, really interesting pattern. So if you're looking at like the mainline kernel release, you're typically going to see a lot of communication, and it's usually very positively valenced. I'm talking just running NLP over these systems. Positively valenced, you'll tend to see an uptick as you get closer to a release of people just engaging in what they think the next kernel release needs to be. And then it turns to like neutral or negative language about the month before the release. That's when we're taking out anything that we cannot make a guarantee that works or does not have a security concern.
Mm-hmm.
And then we'll provide you a release. We're moving very rapidly in open source to moving a lot of our systems over to something that either is the secure kernel or looks much more like the secure kernel. The secure kernel has been in existence since 1962. It's been around. We are looking at 60 years of a secure kernel existing. And in this system, it is driven completely by cryptographic proofs and by ensuring that we can only and explicitly mathematically identify that there are no gaps in that fundamental, like compile level of the Linux kernel before you start to jump up and build your systems on top of it. Because at the end of the day, if your kernel cannot be relied on, there is no open source that can be relied on fundamentally. That's a whole new vector of concerns. So open source is radically maturing in really this 2-year period right now. And it's one of the most exciting times to be paying attention to open source security because it's going to change the way that you approach it as an individual developer. And it's going to change the way that your career evolves because your relationships to security are going to change as the systems absorb some of the liability that was on individual developers before this. And on behalf of all of these open source stewards, I'm going to take the liberty of saying we are sorry for putting all of that onus on individual developers and maintainers. We have seen that it does not work. And we are trying to make this a world where it's a creative domain again, instead of a security domain, whether or not you want it to be.
Thank you so much for sharing that. So now talking about like the foundation of things from the kernel, trying to make sure that they're secure and all of that. I like us to deviate a bit to like the code base. Now, this is a question that I have heard so many people talk about when it comes to like security and open source, right? And with the introduction of generative tools and AI, so many persons now rely solely on the source code that they're getting from generative tools to just copy and paste in the open source project and move on, right? Is it possible that vulnerabilities can be introduced into these generated code bases for people that don't even like pay attention to the code base that they're copying? Is it possible that vulnerabilities can be introduced into it and eventually like have a ripple effect on the open source project they're contributing to? And if not, is this something we should be scared of as well?
Yeah, so I personally don't have any problem with people leaning on AI or generative tools to get started with developing out their code. But I have been playing with this for a couple of years, and like I got so frustrated last week because I was like trying to like put something together, and I was like, let me just throw this in because it was a very simple API call. It was getting API calls wrong, which like I handed it exactly what it needed to do, and it's like you can't get this wrong without literally hallucinating the API call. So I would just say, like, security concerns aside, it may actually slow down your development if you're doing something that's relatively simple, in my experience. But if you don't know and you can't catch the mistakes, if you're not used to reading your own code, you won't be able to see that in real time. So I would consider it, I don't even consider it like a peer coder. It's like having an extremely junior engineer that you need to know is going to make extremely stupid mistakes. And this is across platforms. So, like ChatGPT, not super great at code. Claude, a little bit better, but all of them make these very, very stupid mistakes. And the real concern of the class of vulnerabilities that are coming in through generative AI is something called a composite vulnerability. So it's going to make suggestions to you about what kind of projects that you should import. Now, if you're going to take some of the best practices that I just asked you to do, you're going to go in and say, all right, it wants me to import these 3 packages. Let me go see if these are, one, maintained at all, and number 2, if they're maintained with security practices. If not, I might not want to be consuming those, even if the AI says that, oh, that's the only thing available. That is not true. Now, you might be getting asked to import things that are insecure, so you have to pay attention to that. Number 2, you might not be able to know if you're getting a composite vulnerability. So the log4j, log4j, log4shell case, if you had just installed that package alone, it was not vulnerable. That was not vulnerable. It's just a logging mechanism. However, if you imported both log4j, log4shell, and a package called JNDI, you had to have both of those packages in place in order to have the severe vulnerability where someone was able to just go in to where they'd usually be putting, here's my login information. They could put in a query and it would pull out whatever they wanted to. That's a composite vulnerability. And composite vulnerabilities that are logical vulnerabilities that fit in the interaction between packages are extremely hard for us to be able to scan automatically at this time. So there's secure component analysis, or SCA. That's typically what you're going to run over a group of packages that you are looking at to see if there's been a recent vulnerability that has come up over them. And you may be looking at something that's been sitting on the internet for 7.5 years without a known vulnerability. But in fact, it is the reason why you have an extreme vulnerability. So, composite vulnerabilities, these are things that you're only going to be able to identify, one, by looking at the 0 days and seeing the massive exploits, or number two, actually having an understanding of what are the logical vulnerabilities that sit inside of your system because of the language that you use, and are any of these packages connecting to any of the other packages that you're using logically in a way that could give you a new and unknown security vector that you can, at this time, really only identify by doing a pretty much line by line logical analysis?
Interesting. Okay, so you heard Sal. Always look out for what you're putting in your open source project, whether it is you're contributing or you're building a project. And now I'm curious, right? You have been doing this for a couple of years, and I just have a lot of imaginations. Are there like challenges that you have encountered through the years while contributing to open source in this field? And are there opportunities that you have also experienced?
Yeah, so I mean, cybersecurity is a really big space, and there's lots of different ways to engage with it. But around open source, it gets to be really, really fun. So there's two ways that are really good to get started in open source security. If you want to get started, look out for bug bashes, paid ones or not. These are really, really good opportunities to sharpen up your understanding of usually language level vulnerabilities. So you'll go in and you will so they'll identify a couple of bugs that need to be fixed or vulnerabilities that need to be fixed in open source systems, and you as an individual can come in and contribute to those. So I was working a couple of years ago, and we did a large bug bash for CNCF, which is the Cloud Native Computing Foundation. They've got about, or I think now, over 200 projects, and we identified projects that wanted to do bug bashes. We put up a leaderboard and we gave credit and awards to those that participated the most in it, which was a really, really good way at the time of getting the like common contributor to these open source projects to have their first experience of thinking about also being a security contributor to the projects that they're already taking in. So being an active participant in making sure that the security standard for what they consume is solid. Everyone benefits from that. The downside of that is that you're dealing with it way too late in time. The bug is already there. We've made it public. We know that we're going to patch it immediately because of the bug bash, but I'm way more interested in preventative care. So there's also there's a new security slam that's coming out next month in March. So security slams are a very, very different approach, and we've been running these for about 3 years over CNCF projects. And what those do are really focus on the persona of the maintainers of the projects and helps them to do everything around putting those security baselines in place so that we don't get to the spot of having like dozens or hundreds of bugs that we need to manage. Because you can get in feature engineering, it's all right. You can have a backlog. You cannot have a security backlog. That is just not a reality. Once you get into a security backlog with an open source project, if you can't fix it, that's going to go to a security graveyard. It cannot be used, it cannot be imported. If you're really serious about the project that you are building out, or you're really serious about a project that you're consuming, like if it were to leave the internet, you could not do your work without it. Number one, go and reach out to those maintainers. Are they happy? Are they enjoying doing security baselines? Do they want committer assistance with that? Like, do they want members of community to get involved? They may say yes, they may say no. But when you're looking at these, it's a really good way of choosing some of those tools that I've given you, right? Like run an OpenSSF best practices or score badge over those projects if they don't have a score already. You can also go and search in the database. If anyone at any point in time has run a security analysis on them, that's always available for you online. So you can go in, check the security status, see if there's any security bugs that you want to pick up, and also go and look at the moments in time where maintainers are actively reaching out to their contributors to get more assistance. And those are things like the CNCF Security Slam, which is happening over the KubeCon EU. So that's early next month. And I do believe that there can be just external online contributors to that. So that's a really, really cool way of, even if you don't contribute, you can watch a couple of projects go from like zero to hero best practices in
Mhm.
a couple of hours. Look at all of the deltas of everything that they've changed in their code or their operational practices and choose to use those yourself. One of the very basic security things that I always try to get people to put into place is like merge control. Like just make sure that nobody can merge to main without someone doing a review. That's very simple. And if you've got more than two contributors to your open source project, that kind of thing should already be in place. It's really that simple, and that's just a matter right now of pushing a button on GitHub or GitLab.
Awesome. Okay, thank you so much for sharing that, Sal. And just to wrap up, I have one more question. Assuming you want to give an advice to someone who wants to get into open source security, based on current trends, what is the best way you would suggest someone to get started? And how can they position themselves for success in this field?
Yeah, so right now, if you want a job in security, there are a couple of serious, serious factors that we're still going to be dealing with for the next 5 years. And in security, as with every field of engineering, every 2 years you have to basically upskill into a new stack, or a new release of the stack that you've got. So you're always learning. But right now, make sure that you have a clear understanding of exactly what supply chain vulnerabilities are, what the likely supply chain vulnerabilities are for the ecosystem or language that you are looking at are, and what the mitigation strategies are. That is where most jobs are right now, in making sure that yes, we have to use open source. We are importing open source from all over the internet. We do need to make sure that there's hygiene in place for those to be absolutely secure in our production spaces. So that's a very, very, very good place to get the core of your learning and your understanding. I'm also saying that in terms of something where I want you to go out and get portfolio experience. So it's one thing to go take a course and get a certification. It's a very different thing when I can look at someone's GitHub and see that they have been engaging in some level of security practice on open source projects. So this is where I want you to go and pay attention to bug batches, security slams, any of those opportunities, particularly if it's in an ecosystem that you're already participating in. That's where you want to jump out and, fix a couple of bugs, write a couple of blogs on these things, because there is just not enough communication out there. And I can put out blogs all day, but what I'm finding to be more interesting to me now is the persona and the experiences and the blogs that are getting written by people who go out and have their very first experience in security, whether it's their first time doing a bug bash, their first time engaging in supply chain vulnerabilities at all. There's such a mass of understanding, and it opens up the lid of like, oh, was I just ignoring some major issues that, if I did not have any security awareness, I would have just blissfully continued to move on in my life and waited for a 0 day. You want to become a completely different developer. You want to become the kind of developer on your team that's going to make sure that you're doing preventative care 100% of the time, saving yourselves hundreds of developer hours across a year, if not thousands if you have a major breach. So go out and demonstrate your experience on simple fixes. So if you're doing these bug bashes, they're typically like small logical vulnerabilities. They're very small things that are not going to take you more than an hour or 4 hours if it's a major vulnerability. And in that process, it's better or more interesting to me to see you engaging with a maintainer around, hey, I think I patched this as a security concern, and to look at how the maintainer responds to that, how they want to intake it. That gives you a really, really interesting perspective. Some of these projects, right, because we're in real security at this moment in time where it's not standardized. So you may go and push a PR that looks like a bug bash sort of fix. They may say, please take that down and send it to me by email on my security MD email. That is really right now by project and by their individual best practices. So jump out into that Wild West and see if you can do some defensive engineering at a really, really small scale. See if you enjoy doing that. See if you enjoy working with the maintainers on that. But definitely show and demonstrate that experience, because right now there are absolutely not enough people that are claiming to want to do cybersecurity that have done it at all. Having a certification does not count. Going out and working with an open source project as a completely junior engineer, going and focusing in on one project or one language and getting 2 or 3 of those is going to demonstrate more to me as a hiring manager than a dozen certifications, flat out. That is still, and this is like the reason why individual developers do open source is because, one, we have ideas that we like and our paid managers don't always like them, and we're going to do them anyway. So that's part of open source. But when you're just starting out in open source, it's really about demonstrating your capacity and your portfolio. And when you have those, if I even had someone that did one security patch, demonstrated that to me on GitHub, and then said, I had this experience and I don't think I want to continue doing security, I would still be more likely to hire them than someone who had never, ever engaged in public cybersecurity practices, period. Because there's so much that you'll learn, so much that you have to understand. And when I say so much, I'm talking like a couple of hours of diving deep into the content that things like Linux Foundation or Eclipse Foundation have already provided to you. But just going and doing those little fixes, showing publicly that you're engaging in security, it's always going to be the best answer for getting a job in open source. So that's the best answer for getting a job in security.
Awesome. Thank you so much, Sal. And this has really been insightful. If you learned so much from Sal, just as much as I did, do well to comment. This brings us to the end of our today's section. Thank you all for joining in. If you also want to catch up on more sessions and stories from open source diaries from different fields and industries, do well to subscribe. And that being said, that'll be all for today.